So what I'm sharing in this video is a fully parametric tutorial that shows you how to create this design, starting with the base geometry, then creating the structural members, and then the outer frame. And so what I do on this channel is share with you parametric designs of structures so you can learn the process of creating these parametric designs so you can create them on your own. If you want to get a hold of the resources and the script that I made in this video, check out my website, capettidavid.com. There you can find the script for free the first week. And then later on, if you join the membership, you'll be able to get a hold of all of the resources and scripts. So thank you very much for being here. I hope you're excited about learning how this works. This is perfect for those of you who are just getting started. So thank you very much for being here, and let's jump right in. So what I like to do is start with a scale person. And the reason for this is so I can see what size I'm making this relative to a scale person. So I'm just dragging and dropping, going to 0, enter. And so now we have a person here that we can use for our reference. Now let's start with our script. The first thing we're going to do is create an arc. So we'll start here by going to construct point. This will create a parametric point here that now we can move to the X and then up. So we'll go create a move component. We'll be using the point as the geometry input, and the motion is going to be in the X direction. Now I can give it a value for the size from the center. So here we are going 15 in the X direction. Now we also want to go 15 in the negative X direction. So I'll bring in a negative component and go from the X positive 15 vector to a negative 15 vector, which will make it 30. So what this will do is this will be the diameter or the overall width. So we have to divide this by 2. So now it'll do 15 divided by 2. And so the overall size is going to be 15. So this is going to be the width. Okay. Now we're going to take the center or the original point, which I do typically like to create a relay and start from here so we can change the location of where we have this design. Now we can go from this relay and bring in another move component, use the point as the input for the geometry, and now we'll be moving this up. Now by default, we have 0, 0, 10, which means it's going to move it up in the Z vector by 10. We want to be able to change that so we can update the overall height for the design. We'll go here, go to height. So now we have the overall size and then the height. Next, we'll be bringing in the arc component. This is going to be arc 3 points. And as you can see here, we have different ways of creating arcs. 3 points is what we'll use because we have the 2 outside points and the center top point. So let's plug those in correctly. We'll start with this as point A. B is going to be the center point. So this is where the one that we moved up is going to be B. And then the last one is going to be the last point. So now it will create an arc between those, and now we can change the size using the sliders. Next, we'll be creating the overall width of it. So we can basically take this and offset it. So how do we offset it? I'll bring in the offset curve. I'll plug in the arc as the curve input for our offset. And it's offsetting to the outside, which is what we want. So we'll bring in a slider. We'll go 1.5. This way I have a decimal point. And we can change the width of the frame. Great. So at this point, we can connect this and this to create a solid. So to do that, we'll go to endpoints component, and we need the endpoint of this one. This way we can connect the start points with the start and endpoints of the offset. So now we can go here, or actually, I just had a bit of a different thought for this. In the time lapse you'll see later, this is the approach that I took, but I'm saying here that I actually may want to do something different. And let me show you what I mean. All I want to do is take this and move it again. So I'll bring in a move component. We'll be moving this in the X direction to the outside. And therefore, we'll be doing the same thing with the other one. But this time, this one has to go in the negative direction. Okay, so at this point, now we've created these 2 points. Now we're going to move the center point up once again by 2.8. So this is where I'll take this, copy it. I'll take this point as the input. It will move it up again, but this time we'll be moving it up in the Z direction by the same as. So this number determines the offset, this offset, and this offset. The cool thing is that we could also have a different variable for the top one, and this will make it so it's not a continuous depth all the way around. It does give it a little bit of variability, which is sometimes what we want to create for these parametric designs. So let's do that again. Let's create the 3-point arc. So you either copy this or bring in another component. Now we'll start with this one. Well, first of all, let's see how this one was organized. This was the first one, which means that this is going to be the first one. Point B is going to be the one that we moved up. And C is going to be the last one. It's a little bit different than offsetting. This is offsetting, but using the numbers and also creating a little bit of variability in this area here. So now we can take these and do what we were going to do before, which is bring in the endpoints. Now for this one, we already have the endpoints. So we have this and this. We can create a line between those two using a line component from start point to endpoint. And then same thing with the other side. Starting here, ending this one. So here we have our 2 line segments that join the 2 arcs, and now we can join those together. Using, I keep bringing the wrong one, vrep join. We'll use join curves. So we'll use the first one, second one holding down shift. And so we plug all of them in, flatten the input, and just make sure that for the output, you have a closed planar curve, which means that it's closed. Now the next steps are going to be to extrude this out. So we'll take this and we'll go to, well, we can extrude it or array it, but for this exercise, we'll go to extrude. In which direction? In positive Y direction. So I'll plug this in. Direction, unit Y. Value, I'll say 50. What happens is when you have it open like this, you won't have it closed unless you cap holes, which will close it off, or the one that I like better is using boundary surface, because when you extrude a surface, it actually turns it into a solid by default. And then we can also use that surface if we needed to, and we also have the curve. So with this, now we have our base form. So now I'll relabel this one as frame offset. This is going to be frame offset 2. And this is going to be structure length. Like I mentioned, I am going to show you a time lapse after this of a different approach, very similar, but I took a bit of a different approach. So now we will be creating the portions in here that have like the members going across here. So that's the next step. For this next part, we need to take that original point and move it all the way back and create a line segment that we'll use to divide into points. So we'll go to move. I'll move this down. We'll start with the original point, moving it all the way down the same length as the structure. I'll bring this component all the way over here, use the length to move that, and now we have the original point, which is this one, that comes in here. It gets moved 67 feet to the end. This is a point, and I just created a relay here so I can easily use this input. Now I'll create a line segment between the endpoint and the start point. Now I can divide this evenly or by a length. So I'll go here just to divide curve. We'll use the line input as the input for curve, and now the number, we'll just say 4. And actually, this is a better approach. We'll be using just the midpoint of that line. Now we need to move this line, this point, to the left and to the right, making sure that it's always more than or larger than our structure. So we need to move this point in the X direction by half here, but that is going to be the width, which is divided by 2. So we can use before it divides by 2 to move it in the X direction. This way it will always be there. Unless the arc is really tall, then this might come out here. And now we'll do the same thing, but this time in the negative direction. So we go the opposite. Now we have a line segment that we can create between our start and end point. Next, we'll be turning this into a solid. So there are 2 ways of doing this, either offsetting this, creating line segments in between the 2, and then extruding it, or extruding it and then extruding it once it's already a plane. So that's what I'll do. I'll go to extrude. In which direction? In the Z direction. But this time I'll be using the arc height. So arc height is this one, and we know that we use the arc height plus the frame offset. So we moved it up by 4. So it's going to be the addition between 26 and 4. That now we can use as our extrusion in the Z direction, and we can also add vectors. So we are actually just adding numbers and then setting a vector. But if we have two z vectors, we can also add those vectors directly without having to add the numbers and add another vector. But this just shows you where and how it's extruded. Now we can take this and move it. This technique is to turn a surface like this into a solid. So we'll use this extrusion. We'll be using amplitude to extrude in perpendicular to the surface. That's going to be the motion. And then when we extrude the surface, it's going to be in the negative. So if we move this by 1.5, we need to extrude it. If this is 1.5, we need to extrude it by 3. So that's why we do times 2, whatever this number is multiplied by 2, and in the opposite direction, so negative. So now this number is going to be the depth of that thickness, and this has to be divided by 2 because we're extruding to both sides. So to get a true value between the two, not from the center, we can use this. Now with this box, we can rotate it to create the frame. So now we'll take this and we'll go to rotate. We'll be using the extrusion as the input. The plane is going to be the midpoint. So that's going to be our midpoint here. And the angle, we'll use degrees and we'll just say 15. And at the same time, if we do 15 positive, we can also do 15 negative, or we can mirror it. So those are two ways of doing it. We'll do 13 and then negative 13. Now we can disable the preview on the original, although we could use that if we wanted to. Now these two will bring together using Boolean union. So we'll go to union, solid union between these two solids. And now we can array this, move this in the X or in the Y and then negative Y, or Y and then mirror it. So this is where we can take this. We can go to move. In the Y direction. And we will be creating a series, so more than one number as the input. The count is how many, so we'll just say 3. The step or the spacing is by how much, so we'll just say 15.5. So we have 3, and we can add more if we wanted to. Or if we want the spacing to be less, or if we want only 2 on this side. Now we can take, let's see here. And starting, it's going to have to be here. So this is where we can lower it here and take this last one, go to our midpoint, and create a plane that is X, Z to mirror this side. So we'll go here to X, Z plane from the input. And this is going to be what we use to mirror. So we'll use plane input. That's the output. As you can see, one of the things that is interesting is that when you rotate it enough, there will be a time in which it won't intersect. So this is why sometimes I'll go back to the curve input, and if that's not enough, then I'll do this. Extend the curve. So we can extend the curve at the start and at the end. As you can see here, using this, we can extend it more and use that as the input. So now we're extending this a little bit further, just in case we need to. And then go back here to our rotation, kind of bring it back a little bit like this. And the spacing like so. Okay, so now at this point, the fun part, we can finally see the work that we've been doing. We'll be taking all of these, let's put them into a brep component all at once. So we know that they're kind of all organized like so. Flatten the input, so that's the only thing that we see. It's one long list that's organized. And organizing some of this stuff so it's a little bit easier when you check out the file on my site. So now, okay, at this point, let's disable the preview on all of this stuff because we don't necessarily need to see it. Now we're going to go to our solid that we created down here. We'll go to intersection, solid intersection, and we want to keep this, but we want to intersect it with, and sometimes it's like a backwards thing where this actually goes here and this one goes here. So I'm creating a relay so it's a little bit easier for me to do that. Okay, so that was the trick. It was using these, which are the ones that we want to keep, and intersecting with B, which is the overall form. Now we can disable the preview and we can finally see some of our design. If we wanted to add more, we could, but just the spacing would have to be smaller like this. Now our rotation can increase. And at the end, these could be put together all as one. Now, these are all separate, so it might be easier to use solid union and flatten it before we do the intersection. Then do merge all coplanar faces, so we make sure that we remove all of the creases. Now we can use this brep here as our input, and that will actually clean up some of our work here. Now, and makes sure that that is a solid throughout. Now we can go back to our original, go back here and disable the preview so we can see inside. So this would become kind of this header in a way that would connect to the front frame. And all of these aspects can be updated and changed using all of the sliders here. So one, fine. Some of these, it looks cool when they overlap and create kind of some openings like this, but they connect here at the bottom. So this is the subtleties of creating. And the cool thing about creating parametric designs is that with your sliders, you can see the limits of your design and therefore make better decisions. So now at this point, we've got the frame or the structural portion. We've got the overall form, which is this one. And now I want to show you how to create the inner frame so we can have these as openings, but also have this on the outside. So there are so many different approaches, but I'm going to show you a straightforward one that is very practical and that you can use on many other of your designs. So at this point, we'll take the overall form and create a box around it. This is called a bounding box, and you can do that by bringing in a box component, and whatever you plug into a box component, it's going to create a box around it, but it has to be aligned to the X, Y coordinates. There are other ways of doing this, but this is going to be that practical way that I want to show you. So with this box that is all the way around this, now we can take that box and move it in the Z direction or up. And this is going to determine the bottom portion of the frame. So moving it up in the Z direction, I'll use 1.5 to move this up. Now I'll take, now that it's been moved up, now we can scale it in one dimension. So I'll take this and go to Scale, Non-Uniform. I'll use the geometry or the box as the input. Now I'll scale it in the Y dimension. So I'll go here to 0.888. And the plane is from where? So we need to use this, bring in an area component, and use the center, the centroid, as a plane input. And the scale is going to be in the Y direction. So now, notice that I don't use a number like I used here, 1.5. To move this in 1.5, I'm actually doing 0.8 of 1. So if the entire size of it is 1, if we decrease this to 0.8, or 0.9, is going to be 0.9 of the overall size. So 91% of the overall. This is useful because now it only intersects with the frame, and on the inside it's not going to subtract the entire thing. So this is going to be useful when we do difference, for solid difference between the arc, which is going to be the form that we want to keep. So that goes into A. In geometry, the box is going to go into B. So this is how we can control. Let's disable the preview. So now that it's intersected, now we can control the bottom portion at what side where we want it. We can control the scale of how far in we want this. And at the end of the day, there's one last thing that is critical. And that happens to be that this is the intersection of this portion. But if I show you the box, if I intersect the box with this, it will give me the frames before. It'll give me the structure before the frames without them overlapping. Hopefully you're able to see how all of this interacts together. So let's go to intersection, solid intersection or Boolean intersection inside of Rhino. We'll be using this as B and this as A. Okay, sweet. Now we can disable the preview on this output, keep the portion that we want, and disable the preview on the box. So at this point, now we have all of it taken care of, and it's perfectly aligned because we're using Boolean intersection of multiple things, and therefore it makes it perfect according to our script, of course. So here, let's go and organize a little bit of what we have here. So we have 2.6. This is going to be frame base. This is going to be frame scale. This will bring into a geometry component and disable the preview and group it here so I can see that that is a critical component. So now here we'll go to 1. So let's go to, this is called structure size. This is the extension of that line segment. This is the structure length, offset, offset 2, height, width, and this is the point where we can change the point location. So these are some of the things that I do when I create the clusters, is clean up some of the work so we can change the location. Now I can move this to a different point. Let's move on to the rotation. So this is cool. And then here we have the spacing, structure spacing is going to be the structure copies, because we can always lower this number for the spacing, and at some point it just kind of gets jumbled like this, but we can increase more of these and more will intersect. It does have some pretty cool capabilities here. Now we'll go to count, number of copies, so group. And I mentioned this a few times, but at the end here, I'll also be sharing a time lapse of a different approach for the base geometry and for some of these things. But I actually like this one a little bit better, so just know that there's more information in different ways to approach this. So I'm saving this now. Thank you very much for being here. If you want to get a hold of the script, check out my website, capettidavid.com. There you can find the script for free for the first week, and then you can get a hold of the script and a lot more resources if you join my website membership. There you can find so many different resources. Get in touch with me. And so thank you very much for being here. Hopefully you found this useful. I hope you're excited about getting into parametric design. In my opinion, it is super useful and a very good way to kind of continue your learning in architecture or in design. So I hope to see you on the next one.